真
假如真的存在万能的上帝，他一定踊跃的、偏执狂般的思考，把爱压制成信息，隔离开人们，用悲剧的法则撕裂我们的心。假如它真的存在，我想去试着祈求，给我一个保证，让我一直在你身边，在你看得见的地方，并有亲吻你的力量，用我不悠扬的歌声温暖你整个旅程。飞，飞上，飞上。假如它真的存在，我想去试着祈求，给我一个保证，让我一直在你身边，在你看得见的地方，并有亲吻你的力量，用我不悠扬的歌声温暖你整个旅程。飞，
很累不了。 Okay, guys, can you hear me?
Yes, Laushi,
Yeah,
we
Lao
can hear
Sư.
you.
Okay, and the
Yes,
song,
Laushi, we can hear you.
the song I played called Fei Fei Ran. I will write here.
What's the band's name, Laushi?
Yeah, the song's name is the girl's name.
Fei Fei.
Yeah, her name is Ran Fei Fei. So this is
Okay.
yeah, it's a love story that the singer wrote for a girl, and they met during his trip on the train. So it's a romantic story, but they broke up after the trip. So he write a song for her. So this is the story for this song. I know most of you cannot understand, but I think so. I will briefly tell you guys the story about the songs behind the songs. Okay.
Mm.
Yeah. Okay. So let's move on to the third lecture. And before we learn something new, do you want me to explain the homework for you? Last time I leave the homework, right? So, are there any questions about homework? Do you remember that?
Yeah, you can describe about homework task.
Yes, Lao Sư.
Yeah, so I left for exercises last week, right? And I think number 3 and number 4 is easy. They are easy to calculate. But the first and the second one, I think that is a little bit difficult for you. So first, we will solve the homework for the first 2 questions. And the first, that is to calculate the limit as x approaches 0 and the function that is tangent 3x by sine 8x. So before we solve this question, can you remember we have learned one important limit last week, right? That is, as x approaches 0, sine x by x equals to which value? 1. Yes. And I want you guys to remember another 2, right? That is, as x approaches 0, tangent x by x also equals to 1, right? And another one, that is, as x approaches 0, x by sine x also equals to 1, right? So you have to remember these 3 and you can use them directly. And furthermore, here, you only have to keep these 3 parts the same. Then you can use these 3 formulas. That means a more general type. So here can be 3x or 5x. And here we should only get 3x or 5x. Here 3x or 5x approaches 0. And we know if x approaches 0, then 3x, 5x, or more general kx also approaches 0, right? So you only have to multiply some constant here to make these 3 parts the same. Then we use the so here for the first one, we found that here we can see tangent x and sine x. So we know we will use the second one and the third one, right? But before we use it, we must change the function to another type to meet the type of the formula. So here, if we want to use this formula, here we find that is tangent 3x here, right? So we should write 3x here. And to make it the same, we should times 3 by 1, right? So here, 3x by 1. So here, 3x can be cancelled. That is the same as tangent 3x. And here, another part that is 1 by sine 8x, right? And here, if we want to use this, the third formula, we should write 8x here. But to make it equivalent, we have to time 1 by 8x, right? So here we have changed the function to the type we want. That is, as x approaches 0, the first part, that is tangent 3x by 3x. And second part, that is 8x by sine 8x. And the third part, that is 3x by 8x, right? So here we know that the limit of the first part, that is 1, and the limit of the second part, that is also 1, approaches 1. So the limit of the original function, that equals to 3x by 8x. And x can be cancelled, right? So here we know that the limit of the first question, that is 3 over 8. So this is the result of the first one. Can you understand, guys?
Yes.
Yeah, because we have do a lot of exercise last week. So I explain it very fast. So any questions?
No, 老师.
No. Okay, good. No question, right? So number 2. Okay, number 2. Number 2, that is to calculate the limit as x approaches 0. Here x plus x times cosine x by sine x times cosine x, right? So how to calculate this limit? First, we will use that we have talked about, that a plus b over c equals to a over c plus b over c, right? So here we can separate the function to two parts. That is, as x approaches 0, the first part, that is x by sine x times 1 by cosine x. Here, I will write more steps here. Oh, sorry. The first part, that is x by sine x times cosine x. This is the first part. And then plus x times cosine x by sine x by cosine x, right? And then we separate the first part again. That can be separated by x by sine x times 1 by cosine x, right, guys? And plus the second part, cosine x can be cancelled, right? So that is x by sine x. And here, as x approaches 0, we know the limit of this part, that is 1, right? And the limit of this part, that is also 1. And so here, the limit is changed to calculate the limit of x approaches 0. Here, that is 1 by cosine x plus 1, right? And how to calculate this limit? We just substitute x equals to 0 into the cosine function, right? So cosine 0 here, cosine 0 equals to 1, right? So here we know. Can you understand, guys?
Yes.
Yes.
Yeah, 老师.
Okay. So here we can get the result that is 1 plus 1, so equals to 2. So any questions about this one? Do you have any questions? No, right?
No, Lash.
No.
Okay, good. So this is the first two exercise we left last week. And the third and the fourth one, we know we can take the highest power, the constant before the highest power, right? To get the final result we have talked about last week. So this is the homework part. And then we have to review something to make us learn this week knowledge more easier. So here, please do the following question. That is, if I give you the function, that is, if x is larger or equal to 0, then the function equals to x plus 2. If x is smaller than 0, fx equals to x minus 2. So my question is that the limit of fx as x approaches 0 exists, and why? So please complete this question.
Laoshe,
Yeah.
we have to send it on WeChat, right?
Yes.
Okay, thank you.
Because this question is related to the things we will learn today. So you have to complete it first. And guys, please change your ID with your student number and your name. Student number must write before your name because every time I spend plenty of time to find who is in, who is not. So please to change your name and that will be easy for me to find the attendance. If you have completed the question, please try to draw the graph of this function. Uh, the question is not so hard, and I found most students can give me the correct conclusion, but the procedure is not up to the standard. So here, please pay attention to the steps you write. So first here, if we want to know if the limit exists, so first we have to know that the limit as x approaches x0 fx exists if and only if left-hand limit exists and the right-hand limit exists. and they are equivalent. So here we know that is x approaches x0 here minus, that means left-hand limit, and should be equal to right-hand limit. X approaches x0 here plus. So here, if these two one-sided limit exist and they are equivalent, that we know the limit exists. So we first calculate the left-hand limit as x approaches 0 from the left. Then the function here, we know if x approaches 0 from the left hand, that means x is smaller than 0. So here the function, the expression of the function, that is x minus 2. So here we write x minus 2 here as x approaches 0 from the left. And we know here equals minus 2. And then we calculate the right-hand limit here, that is x approaches 0 from right. Now, then here, that means x is larger or equal to 0. So here we know the expression of the function, that is x plus 2 here, right? So here we know x plus 2 as x approaches 0 from right. So here we can find the limit equal to 2. Then we know that left-hand limit does not equal to right-hand limit. That means the limit of fx as x approaches 0 does not exist. So this is the standard procedure. Here, don't forget to write the function. Don't forget to write the function. And then don't forget to write the limit sign. Don't forget to write the limit sign. And here, to distinguish left-hand limit and right-hand limit. That makes a perfect procedure, and you can get full marks. So here, for this question, we know the limit does not exist. And here, we can draw the graph of this function. For this function, we can see, I will draw the graph here. This is x-axis, and this is y-axis. This is the original part, a point. So here we know x plus 2, y equals to x plus 2. Y equals to x plus 2 as x is larger or equal to 0. How to draw this graph? Here, we find two important points for this line. This is a line. And first, we let x equals to 0. And then we know y equals to 2. So here we know the line passes the point 0, 2, right? So here we know that passes 0, 2, this point. And we know that if y equals to 0, then x equals to minus 2, right? So the line passes minus 2, 0. So here the point that is minus 2, 0. So we know that the line should pass these 2 points, but x is larger or equals to 0, right? So here we only have to draw this part, and this part we don't have to draw it because for this part x is smaller than 0, right? So this is the graph of the first function. Then we draw the graph of the second, that is y equals to x minus 2. Here x is smaller than 0, right? So here we know we use the same way. We find 2 points here. If x equals to 0, then y equals to -2. So here we know that the graph passes this point, 0, -2. And the second point, that is, if y equals to 0, then x equals to 2, right? So that point is 2, 0. So this point. So we know this line passes these 2 points, and we want the part that x is smaller than 0. So we only have to draw this part. And don't forget it, if x equals to 0 here, if x equals to 0, y equals to 2 here. So this point is a hole, So this is the graph of this function. Can you understand how I draw this graph, guys?
Yes, 老师.
Yes?
Yes, Lasha.
Okay. So here, if you see 2 graphs of 2 functions here, the first graph, that is a line, maybe like this. And maybe this is the graph of y equals to x. And the second graph, that is like this. So we can know from the graph that the first line, that is a continuous line, right? And the second line, that is not continuous, because here we can find discontinuity, right? Can you understand, guys? Yes. Yes, so we can see from the graph directly. So now we will learn what is the definition of continuity in math. So here we will learn, and this week we will learn continuity and discontinuity. They are important points in the first chapter. So here we will learn continuity first. Continuity. First, we learn continuity at a point. What is continuity at a point? And that means first, we will learn a concept that is increment. Of variable. What is the concept of increment of variable? Here, I will also draw a curve here. Maybe the curve is like this, and this is the graph of a function y equals to fx. Here, I let the first point, this is the initial value, that is x1. And here, I gave a terminal value, here, x2. Here, from x1 to x2, we can find the increment of x here. That is x2 minus x1, right? And we gave a symbol here, that is delta x. Here we draw a triangle here, and then x, but we call it delta in math. So this means increment of x, that we use the terminal point minus the initial point. And as the independent variable x changed from x sub 1 to x sub 2, then the value y also changed. So we know if x equals to x1, we can find the value here, that is f of x1, right? And here, the terminal point that we know the value of y, that is f of x2. So we know the increment of the variable y. So here we can also get increment of the variable y, or we call it dependent variable. So here that is f of x2 minus f of minus 1. And we gave it also a symbol that we call it delta y. That means the value of y changes from f of x1 to f of x2. So here that is the definition of increment of variable. And what means continuity? We say that continuity here we say if the increment of x approaches 0, then the increment of y also approaches 0. Then we call that the function is continuous at this point. So we can write it as delta x approaches 0, then delta y approaches 0. So the limit of delta y as delta x approaches 0 equals to 0. For example, as the time changed, the temperature also changed. That is continuous. And as time changed, we grow up. That is also continuous, right? So here, that is this is the definition of continuity in math. We use the limit, the two limit, to show the definition of continuity. And there is another form. There is another form to write if here we let delta x equals to x minus x0. So here, x0 is the initial point and x is the terminal point. And delta y here, that is f of x minus f of x0. So we can get another type of continuity, that is, as delta x approaches 0, that means x approaches x0, right? Here, delta y approaches 0, that means fx approaches f of x0. So we can also write it as a limit, that is, as x approaches x0, then the limit of the function fx equals to fx of 0. So this is another type to describe continuity. So here you should remember two formula. The first, that we use the increment of variable. And then the second, we use the limit. And we use this type. Mostly, we use this type. So remember that. And here we know, as I have written it above, that what means the limit of fx exists. That means as x approaches 0 from left exists. The left hand limit exists and the right hand limit also exists, and they are equivalent. That means the limit of this function exists. So here, as we have left hand limit and right hand limit, we also have one-sided continuity. So here we know that if the left hand limit exists and equals to f of x0, then we call it left continuity. Left continuity. And if the right hand limit exists and equals to f of x0, that we call it right continuity. So this is the definitions of the continuity. And here, from this formula, we can get the continuity test. How to test, how to know the function is continuity at a point. So here that is continuity test from the second definition of continuity. First, we see the left part. That means the limit should exist. And then the second, we see the right part. That means the value of x0 should exist. And then the third, that is, these two values should be equivalent, should be equal. So we have the second, that is, these two values should be the same. So we call it continuity test, and we use this test to check if a function is continuous at a point. For example, I will give you an example as I have given it above. That is, if we know the function, that is, if x is larger or equal to 0, that the expression is x plus 2. And then if x is smaller than 0, the function is x minus 2. So here I have three questions. The first one, and you have to check. The first one, does f of 0 exist? The second one, that is, does the limit of fx as x approaches 0 exist? And the third one, are the two values the same? That is, does the limit of fx as x approaches 0 equals to f of 0? So then we get the conclusion that is the function f continuous at the point x equals to 0. So if we want to check if a function is continuous at a point. We just follow the 4 steps. Then we can get our answer. So here we answer the first question. That is, does F0 exist? So guys, do you know if the value of f of 0 exists? Can you guys answer me? All of you do know that?
I think it doesn't exist.
Doesn't exist? Others? Do you have any idea? For the first question, F0. No.
I think it exists according to the 3 continuity tests.
So here, guys, look at the function here. How the function defined determines if f of 0 exists. So here, what it means, f of 0 exists or not, we should see the function. Here we can see x is larger or equal to 0, right? So if x equals to 0, then the function that is x plus 2, right? So here, f of 0 should be equal to 0 plus 2 equals to 2. So f of 0 exists. F of 0 exists. Can you understand, guys?
Yes.
Yes.
Yes. So here we know that f of 0 exists. So look at the function to find if the value of this point exists. And then the second question, does the limit exist? And from the above, we have know that here, remember that the limit does not exist, right? We have worked it out. The limit does not exist. So back to here, we will not write it again. So here we know the limit of fx as x approaches 0 does not exist, because we know the left-hand limit does not equal to the right-hand limit, right? And the third question, does the two values equivalent? Here we know that the value of f of 0 exists, but the limit does not exist. So the two shouldn't be equal, right? So here, the third, we can answer it. Does not equal. Because we don't have a limit here, right? So they cannot be equal. So here we can get the conclusion that is f of x is not continuous at the point x equals to 0. Can you guys understand?
Can you explain
Yes.
the step 2 again?
Step 2. Step 2 here?
Yes, Lashi.
Okay. Step 2 here. We have to do this question at the beginning of the class, right? Here, as x approaches 0 from the left hand, that means x is smaller than 0, right? So we use this expression. That means x minus 2. So that equals to 0 minus 2 equals to minus 2, right? And as x approaches 0 from the right, we know that here we use the expression of the first one, that is x plus 2. So here that is 0 plus 2. So here is 2. Obviously, minus 2 does not equal to 2, right? So we say the limit does not exist. Can you understand now?
Yes, Laoshi.
Okay.
Yes.
So here, guys, can you tell me, although the function is not continuous at the point x equals to 0, but can you tell me if it is right continuous or left continuous, or neither? Remember the concept of right continuous or left continuous? If the if the right hand limit equals to the value of f of 0, that is right continuous. If the left hand limit equals to f of 0, that is left continuous. So here we can see that the function is
Right continuous.
yeah,
Laoshi.
yes. Because we can see here the right hand limit equals to 2, right? And that is the same as here, the value of f of 2, right? So we know, although the function is not continuous at this point, but it is right continuous, not left continuous. Can you understand, guys?
Yes, we got it.
Yes, Laoshi.
Okay, so I will give you another example. You try to solve it by yourself first. Okay, so here I gave you the function that is fx equals to absolute value of x. So my question is the function continuous at the point x equals to 0? So please solve this question. So here you have to follow the 3 steps above to check if the function continues at one point. And it must satisfy the following 3 steps, 1, 2, 3, then you can get the conclusion. Not only the first or the second or the third. It must satisfy all the 3 conditions. Can you understand, guys?
Yes.
Okay. And try to show me your answers. Okay, now let's solve the question together. I think that is not hard, right? So you just follow the 4 steps. The first, to check if f of 0 exists. So the first we know, if x equals to 0, then that equals to 0, right? So we know f of 0 exists. And then we check if the limit of fx as x approaches 0 exists. And here, because this function is an absolute value of function, so we should consider it from the left and right. So we first continue the function if x approaches 0 from the left. So we know here the function that is minus x, right? So here we know as x approaches 0 from the left, then the limit of minus x equals to minus 0, that is 0. And we consider the right-hand limit. Here we know the function equals to x because x is larger than 0. So here we know that equals to 0, that also equals to the left-hand limit. That means the limit of the function as x approaches 0 equals to 0. So this is the first. And this is the second we want. Here we know the limit equals to the value of the function at this point, right? So because here we know that the function, the limit of the function equals to the value of the point, so we know we can get a conclusion that the function is continuous at this point, x equals to 0. So any questions, guys? Okay, if you can understand how I solve this question, so please text one in the WeChat group and let me know who is listening, who is not. Okay, guys? If you can understand, please text one. Because you are so quiet today.
While we are trying to stay focused.
So we are concentrate too much. That's why we are quiet.
Yes.
Okay.
Well, we don't want to interrupt you.
No, thank you guys. And I think the things we learn by now is not difficult, right? It's easy to understand. And we have the steps, we can follow it. And that is easy for us to exercise, right? Why somebody text 3 and 4? What that means? 2, what that means?
That means he is too concentrated.
Okay. Maybe that means you want me to remember you, right?
Yes, Laoshi.
Okay, okay. Okay, then I will give you 2 more exercise to 8. And then we can continue to the next point we will learn. So here I will give you 2 more. And the first one, the function that is x squared plus 1 if x is larger or equals to 1. And then the second, that is 3 minus x. X is smaller than 1 here. So my question is the function continuous at the point x equals to 1, x equals to 1. And the second, the function that is sine x over x if x is not 0. And if x is 0, then that is 2. So please tell me, is the function continuous at the point x equals to 0? So please try to complete these 2 exercises.
Laoshi, I cannot send my classwork on WeChat because my Wi-Fi is gone. I have been using this Zummu on MB and it is from another mobile.
Okay, okay. And and guys, don't submit the homework during the class, okay? So first, let's solve the exercises here. And I noticed some students in and out the meeting room, and because of the electric or because of the internet, it doesn't matter. Just try again to enter the meeting room. Okay, so here we solve the first one. And I found most of you did correct here. And the first one, first we know f of 1 that equals to, we notice that if x equals to 1 here, the function equals to x squared plus 1, right? So here that is 1 squared plus 1 equal to 2. And then we find the limit. If x approaches 1 from left, we know here, from left here, x is smaller than 1, so we use the expression 3 minus x. So here that is 3 minus 1 equals to 2. And the second, we consider the right-hand limit as x approaches 1 from the right hand. So here we know the expressions here, that is x squared plus 1. So here we know that is 1 squared plus 1 equals to 2. So here we know that the limit of the function as x approaches 1 exists and equals to 2. So here we know f1 equals to 2 and the limit equals to 2. So we can get the conclusion that the function is continuous at this point because the limit equals to the value of the function. So we know that is continuous. Okay, this is the first. Then the second. The second, we also first consider that f0, right? F0 here we know that equals to 2, right? And then we consider the limit here. The limit as x approaches 0, that is x approaches 0, that is x approaches 0 means x does not equals to 0. So we use the function sine x by x, right? And we know the limit that is 1, right? So here we know the limit of this function fx as x approaches 0 does not equal to the value of this function at this point. So we can get the conclusion that function is not here, fx is not continuous at the point x equals to 0, right? So this is the solution of these two exercises. So do you have any questions?
So could you please repeat number 2?
Number 2.
Yeah, Laoshi, please repeat number 2.
Okay, so here, the function, if x equals to 0 from this function here, x equals to 0, right? So we know fx equals to 2. So here we got the first value, f of 0 equals 2. And then we consider as x approaches 0, the limit, that the limit exists. So here we know as x approaches 0 here, as x approaches 0, the limit of this function is, if x approaches 0, that means x does not equal to 0, right? So we use this function. that is sine x over x. And from the important limit, we know the value of this limit equals to 1, right? So here we got the second value, that is the limit equals to 1. So here, obviously, we know 2 does not equal to 1. So we know the function is not continuous at this point. Can you understand?
Yes.
Okay.
Yes.
Okay. Okay. So here we know if we want to know if a function is continuous at a point, we can use the continuity test. And that the continuity test, that is to check equals to f of x0. This is continuity test. And if a function is continuous at every point of the domain, that means the function is a continuous function. So here we know the test, that is the function must satisfy 3 conditions. The first, that is f of x0 exists, then the limit must exist, then they should be equal. And from the exercise above, we know some function is not continuous at the point. And the point, the function that is not continuous, we call it discontinuity. Discontinuity. So now we will learn discontinuity. Discontinuity. And discontinuity, there are many different types of discontinuity, and we will learn the most common 3. Here, from the continuity test, we know what makes discontinuity, that the first situation, that is f of x0 does not exist, right? F of x0 does not exist. And that means f of x0 is not defined. And for example here, remember this function, that is y equals 1 by x. And we know for this function, x shouldn't be 0, right? So the point x equals to 0 is not defined. That means f of x0 is not defined. Can you understand?
Yes, Laoshi.
So
Laoshi, please explain again.
Can you repeat, please, Laoshi?
yeah, here for this
Yes,
function,
Laoshi, would you like to repeat, please?
here for this function y equals to x 1 by x here, and here because x that is denominator, right? So we know x shouldn't be 0 for this function, right? So we know x equals to 0, the point x equals to 0 is not defined. Or we can say the function at this point x equals to 0, it doesn't have meaning, right? It doesn't have meaning. So we know this point can be discontinuity. And for the graph here, this is the graph of y equals to 1 by x. And of course, we can see here that the graph, the curve, does not pass this point, the original point, right? So that means this point is continuity. Is discontinuity. Can you understand? If the
So the y result cannot be 0. Am I right? Y result cannot be 0.
For this function, x cannot be 0. But if the function that is y
It cannot be 0, it can be -1, it can be, yeah,
yeah,
it can be +1,
and
it can be -1, but cannot be 0.
yeah, it can be any real numbers, but not 0. Yeah, and for this function, of course, x can be 0, right? And x can be all the real numbers. So we call the domain of this function that is all real numbers, right? But here the domain of this function that is all real numbers except the point 0. Can you understand, guys?
Yeah, I have got.
Yeah, so that means f of 0 does not exist. Okay, guys, because we cannot calculate f of 0. So this is the first case. F of x0 does not exist. And the second that is here, the limit x approaching x0 doesn't exist. So here, there may be one case that is the left-hand limit does not equal to the right-hand limit, right? So that means the limit does not exist. So this is the second type. And the third, maybe the function at this point, the value exists and the limit exists, but they are not the same. Yeah. So here, yeah.
You can have some water.
because I caught a cold, so maybe maybe what
so
can
I'm telling you that
believe me.
you can drink some hot water.
Okay. Thank you. So the third case, that is, they are not the same. So these are the cases. Maybe we will meet in the following questions. And today we will learn 3 types of discontinuity. And the first type.
Nashi, could you please zoom out this page? Could you please zoom out this page? I need a screenshot.
Okay. So wait. So sorry. Oh, what happened? Sorry. Okay, 1 minute. So you want this part?
Last one.
Is it okay?
Last will send us PPT. So maybe you don't need to take a screenshot.
Of course. Okay, so here let's continue. So now we will learn the types of discontinuity, and I will make it larger. Okay, so the first type, we call it removable discontinuity. Removable discontinuity. And here, what is removable discontinuity? That is the value of f of x0 exists, but the limit okay, sorry, I will write it again here. Here, the first type is the value of this function exists and the limit of this function also exists, but they are not the same. So we call this point x0, that is removable discontinuity. And the second, the limit of the function exists, but the function at this point is not defined.
Why it is not defined, Laushi?
One minute, I will give you an example later.
Okay.
So here, the limit exists, but the function at this point is not defined. So we also call it removable discontinuity. Okay, so maybe some students may be confused at the second one, right? So here I will give you an example. Here. Maybe the function here, that is x squared minus 9 over x minus 3. So here, my question is the function continuous at the point x equals to 3? So here you can see for this function, x should not be 3 because x minus 3 shouldn't be 0, right? And that means x should not be 3. And that means f of 3 is not defined. So can you understand?
Yes, Laushi.
Yeah, and that means the function fx is meaningless at this point x equals to x to 0. that means that is not defined. So this is the case 2, right? This case, we know the limit as x approaches 3, that is, as x approaches 3, x squared minus 9 by x minus 3. Do you remember how to calculate this limit?
Yes, Lasha.
Yeah.
X minus 3 whole square.
Yeah, so we know that x minus 3 can be cancelled, right? So as
Yes, Lasha.
yeah, as x approaches 3, that is the limit of x plus 3. So that equals to 6. So here, for this function, we know the limit exists. The limit exists, but the point 3, that is meaningless, right? So we call the point x equals to 3, that is a removable discontinuity. But we can do something to make it continuous. So here we can define. Here we can define a new function that is capital Fx. We can define if x does not equal to 3, that the function that is x squared minus 9, x minus 3. And if x equals to 3, that the function is 6. So here, guys, you can see, we consider this new function that the limit as x approaches 3, that is also 6, right? The same as here. And we have given a new definition here, that is f of 3 equals to 6. So you know that here the limit equals to the function value for this new function. So that means the new function we gave, capital F of x, is continuous at the point x equals to 3. X equals to 3. So we extend the original function f of x to capital F of x to make it continuous at this point. Can you understand, guys?
Can you repeat, please, Laushi?
A bit confusing.
Okay. So for the first part, can you understand why the function f of x is not continuous at this point? Can you understand?
Please clear again.
Yeah, Larry, I think you said it's not continuous at this point because it's undefined, right? Yeah, I got it.
Yeah, oh, sorry. Yeah, the function is not continuous at the point x equals to 3, and we call this point removable discontinuity because the limit exists, but the function is not defined at this point. So we call this point removable discontinuity. And here we want to make the function continuous at this point. So we can define a new function to give the definition at this point. So I gave the new function, that is, if x equals to 3, then the value equals to 6. So this is the function.
How can we get value equal to 6? Please.
Because I find here the limit is 6, right? if I want to make it continuous at this point, then the value should
how could you get x plus 3? Yeah.
Bro,
Bro, because
x
of
square
the
minus 3
numerator.
square. So if you put it in a rule, then it will be 3 x
Will
minus
be
3.
x minus 3
Got it.
into bracket x plus 3.
So,
So,
okay. So for this part, you guys can discuss can discuss during the break, and we will talk about it again after the break. Okay, guys.
Okay, Laushi.
Okay,
Laushi.
Take 15 minutes break. Okay.
50 minutes.
Okay. Okay. 15 minutes, not 50.
Okay, Laushi.
Laushi, how about 20 minutes?
No. 15.
Oh, Laushi,
15,
please,
okay.
20 minutes, Laushi.
No, 50 is okay. 50 is okay, Laushi.
Okay, everyone
50
will
is
come
okay,
after
bro.
20 minutes. Laushi already automatically
Okay, let's take a
5
break.
minutes.
Just go
Laushi will consider another 5
Kudwani,
minutes, no
bro.
problem.
So,
আমার মাথায় তো ঢুকতেছে না
আমার ঘুম
বিদেশে কোন বাঞ্চ
আসতেছে
হচ্ছে এই জন্য 15 মিনিট
আমারও ঢোকে না রে ভাই
Kudwani,
এই
bro.
লাইট বুঝাও আমাকে বুঝাও
জানি গোলাই যাচ্ছে
ও হ্যাঁ
আরে ওমর আছে বুঝা পাস এই
Why you
ক্লাসের
saying
পরে
this?
গ্রুপ স্টাডি করলে হয়ে যাবে
হ্যাঁ
ওটা না বলাই
ইংলিশ
আজকে ক্লাস আছে স্যার
আচ্ছা আমরা ক্লাস শেষে গ্রুপ স্টাডি রাখি এক ঘন্টা
কয়টায়
ব্রেক থাকে তখন
ক্লাস শেষে রাতে করি আমরা রাতে করি
রাতে এই ক্লাস শেষে যে 1 ঘন্টা ব্রেক থাকবো তখন আমরা করি
নেক্সট ক্লাস কয়টা রে ভাই
খাওয়া দাওয়া লাগে না
Bro,
নাকি
he said, go
আরে
for
না
one
খাওয়া
or
দাওয়া এখন করবো খাওয়া দাওয়া কি তুমি চাকরিটা দিয়ে দাও নাকি
তুমি তো করি বাড়া
নেক্সট ক্লাস কয়টা 5:30 নাকি
5:30 নাকি 4:30
তাহলে 4:10 4:10
4:10
Why did you post in a group? You doing the whole class. This was what you were.
থাম তুই এখন
Mind
কে রে
Boston
এটা
Analytics.
কি জানি
গোয়ামার আসছে আমি
এই ব্রাদার হোয়াটসঅ্যাপ
Yeah, bro.
Why are you laughing? Like you are
Because
dancing.
of what Kudwani posted.
Okay, something fishy is going on.
He said during the whole class. Look at he's so confused.
Okay, so you guys are cooking something, right?
কখন গেল
So funny, bro. This mass is very tedious, but we shall overcome it. Why am I still laughing? Let me mute myself.
Why are you mute yourself all? Are you in sleep?
Hey, go on.
রাজীব বুঝতেছ?
কি বুঝি?
ম্যাথ বুঝতেছ?
সব চালের উপরে যাচ্ছে। It is going on my head.
তুমি নাটক
রাজীব এবার
You are a
কথা
drama king.
I'm a drama king. You are a drama king, bro. You understand everything, but you don't say anything about it.
ওরকম মনে হয়, ঠিক আছে?
হ্যাঁ, তুমি মাঝে
প্রচুর
মাঝে ম্যাডামের সাথে তো
বুঝতে
অনেক কিছু বুঝো। হ্যাঁ, আসলে এগুলো
বিদেশি
আমাদের ছিল
পোলাপানকে
না তো, এই
দেখলে আমার
জন্য
না রাগ
প্রবলেম
হচ্ছে,
হচ্ছে।
বুঝছো? এরা বিদেশি পোলাপান করে প্রশ্ন করতে দেয় না, আবার ওরা করেও না, বুঝছো?
হ্যাঁ,
যাই বোঝায় না কেন ওরা ইয়েস কয়, বুঝলো ইয়েস কয়, না বুঝলো ইয়েস কয়।
না বুঝতে আসলে জিনিসটা আসলে খুবই খারাপ।
ওদেরকে এ করতে মানে শিক্ষা দিতে হবে ওইখানে যাওয়ার পরে, অথবা হচ্ছে এই যে ফাউন্ডেশন ম্যাথমেটিক্স এর এক্সাম নিল না, এক্সামের যে রেজাল্ট দিবে ওইখানে দেখতে হবে যে ওরা কেমন পারছে, ঠিক আছে?
হ্যাঁ হ্যাঁ হ্যাঁ, আর একটা কাজ করা যায়, উমরকে বললাম যে বিদেশি গো, এই কি জানি কয়, এই যে গ্রুপ স্টাডি দিতে 10-12 দিন যাতে জয়েন করো না, জয়েন করায় ওটা, তারা তাহলে কেন্দ্র দিব না।
ওই জন্য তো বলছি যে হচ্ছে ওদেরকে একটু শিক্ষা দেওয়া লাগবে।
এটা কই থেকে আসতেছে? মেশিন চালু
জানি না,
গানটা কে বাজায়?
তপু বাজায়।
আরে এটা কষ্টের গান বাজাও মিয়া, ফাইটটা যায়,
তপু
ফাইটটা যায়, ফাইটটা যায়, ফাইটটা যায় গান বাজাও। তপু
হ্যাঁ হ্যাঁ হ্যাঁ,
ভাই
কি গান শুরু করে দিছো মিয়া, এটা কষ্টের গান
মনে
বাজাও।
বড় মনে
ফাইটটা
বড়
যায়,
জ্বালা
বুকটা
ভাই,
ফাইটটা যায়।
তপু
মনে
তপু
বড়
কণ্ঠ
জ্বালা
শুনলে
ভাই।
মনে হয় সবসময় মালের উপরে থাকে।
সারাদিন ঘুম রে ভাই, ঘুমের ছাকা কিন্তু দেখতে পাচ্ছিস না, এরকম একটা অবস্থা।
Okay, guys.
আচ্ছা আমাকে
এই স্টপ স্টপ।
Okay, let's back to class.
Okay, Laushi, okay.
Okay, and I will repeat. Okay, I will repeat what is removable discontinuity again for you. And here, first, here, I will rewrite it again here. Removable discontinuity here. That means first the limit of fx as x approaches x0 exists. The first, but there are two cases. The first, that is f of x0 does not exist. The second, that is f of x of 0 exists, but not equal to limit. So we call the point x0 is a removable discontinuity. Okay, so back to the exercise here, the example here. For this function, f of x here, for this function, you can see that the limit exists and equal to 6, right? But f of 3 does not exist because x shouldn't be 3 here, right? That is meaningless. So we say x equals to 3 is a removable discontinuity. Can you understand? Can you understand?
Yes, Lord.
Yeah. Okay.
How should you repeat what you just said? Repeat what you just said. You said because x cannot be equal to 3.
Yeah.
It means something. I did not get you well. That's why I said go
here. Because for this function, denominator cannot be 0, right?
Yes, Lord.
So x minus 3 cannot be 0. That means x cannot be 3. So we say f of 3 does not exist because x cannot be 3. Can you understand? For example, here, y equals to 1 over x. X cannot be 0, right? That's the same meaning. So we say f of 3 does not exist. So the point 3 is a removable discontinuity here. And that match the definition of removable discontinuity, the first case, right? And the second case here, I will explain. The limit exists, the value exists, but they are not equivalent. For example, we have to do the exercise here. The second one, right? Here we know f of 0 equals to 2 as the definition here, and the limit equals to 1, but they are not the same, right? So we say fx is not continuous at this point, right? And 0 is a removable discontinuity. Can you understand now, guys? Okay. And for the removable discontinuity, we can do something. We can make an extension to make it continuous at this point. For example, for this one, if we want the function to be continuous at the point x equals to 0, we only want the limit equals to the value of the function at this value at this point, right? And we know the limit that is 1. We cannot change it, so we can change the definition here. So we can give a new function that is x not 0 sine x over x. And if x equals to 0, which value I gave here to make it continuous, guys? Here can be equivalent. So the value here should be 2. I will repeat one more time. Here, we all know for this function that the function is not continuous here, right? Because the limit does not equal to f of 0, right? And now I want here to be equal, to be same. So we cannot change the limit because this is the limit we have calculated, that is 1. So we can change here the definition here. If I gave the definition here, if x equals to 0, then the value is 1. We know that the limit equals to the value here. And this function is continuous now. Can you understand, guys? So yes. Here, yeah, we can change the definition here. We can change the definition here to make it continuous. And the example here, we don't have definition here. We don't have definition if x is 3. So if I want to make it continuous at this point, I can give a definition here to make it continuous. And what value I choose depend on the limit. Because the limit here, we know that is 6. And if I want it to be continuous, I want it to be same, then the definition here must be 6 as well. So I gave the new definition here. And then I will give you another exercise. If the function that is x squared plus x minus 6 by x squared minus 4. So here, show that the function f of x has a continuous extension to x equals 2 and find the extension, and I will explain what is the extension. The extension is the capital F of x here. So can you find another function that is related to this function, and that function is continuous at this point x equals to 2? So to solve this question, first we know for this function fx equals to x squared plus x minus 6, x squared minus 4. So first question, first step, do you know which point is not defined for this function? Can you find? Guys, can you find? X equals to 2, right?
Yes, Laoshi.
And x equals to minus 2 is also not defined, right?
Yes, Laoshi.
Yeah, because positive negative 2 squared equals to 4, right? And 4 minus 4 equals to 0, and that is not defined. Can you understand?
Yes, Laoshi.
Yeah. So we know these 2 points make the function meaningless. And then we want to show that fx has a continuous extension at the point x equals to 2. So now we will consider if x equals to 2, then the limit of this function exists. So now we calculate the limit x equals to 2 and x squared plus x minus 6 by x squared minus 4. So can you guys calculate this limit? And if you just substitute, you will find that
5 divided 4.
if you
substitute, it will be undefined.
Yeah, that is 0 over 0, right? So if you find 0 over 0 type, that means there must be a common factor. So here,
And also undefined.
okay, so here we can do something first. That is x squared plus x minus 6 can be written as x plus 3 times x
plus minus 2.
Yeah, and x squared minus 4 can be written as x plus 2. Yeah, x minus
2.
So here we found that
now I get it.
Is x minus 2. Yeah, so this can be cancelled, right, guys? So now,
yes,
you can substitute again. Then we know that the limit equals to 5 by 4, right? 5.
Yes, Laoshi.
Yes, Laoshi.
Yeah, 5 by 4. So here, if we know that the function that is the limit that is 5 by 4. So here we just gave the definition that if x equals to 2, here I will write here. If x equals to 2, then the function equals to 5 by 4, right? And if it's not, and not equal to minus 2, then the function is the original function. So we know at the point x equals to 2. Now the new function capital F of x is continuous, right? Because here we know capital F of 2 equals to 5 by 4, right? And the limit here, x approaches to x squared plus x minus 6. X squared minus 6 equals to 5 by 4, and they are the same. right? So here, capital F of X is continuous at this point, X equals to 2. So can you understand how I get the value here to make it continuous? Guys, can you understand?
Yes.
That's true.
Yes,
Yes,
Laushi.
Yes, Laushi.
Okay, better.
এই বাংলাদেশে যারা আছে ওরা চমক হাসানের ক্যালকুলাস সিরিজটা দেখো তাহলে বুঝতে পারবা।
Okay, and there is one more question here, guys. Do you know the limit here? X approaches -2, and then x squared plus x minus 6, and x squared minus 4. Here, the limit. Do you know the limit?
Yes. Is it not 5/4? It's the same.
Yeah, not 5 by 4.
Mm-hmm.
So the first step, we also
0/0.
right? So the first step, we also cancel the common factor. So we can get that is x plus 3 by x plus 2, right? And here, if you substitute x equals to -2 here, you will get that 1 by 0, right? So here, we say the limit that is infinity, right? And that means the limit does not exist. So you should know this part. Can you understand?
Laushi, go.
That is
Laushi, go over it again. Go
here.
over it again, Laushi.
Here, you know, we can also cancel the common factor at this step and to get this new part, right? And we substitute x equals to -2 here. You will find that that is -2 plus 3, that is 1, and over 0, right? And 1 over 0, that means infinity. That means infinity. So we say the limit does not exist because we have learned that infinity is not a number. That means very, very, very large, right? So here, at this case, we say limit does not exist. But for x approaches 2, the limit that is 5 by 4. Okay, guys?
Okay, Laushi.
Yes. Okay. Okay. And next one. So if I gave you the function that is t squared plus 3t minus here f of t here, t squared plus 3t minus 10 by t minus 2. So try to show that the point t equals to 2 is removable discontinuity. Show that the point 2 So here for this question, we know that at the point 2, f of 2 is not defined, right? And then we want to show that the limit exists. So that means this point is removable discontinuity. So here we just consider the limit of ft as t approaches 2. So here we can get that is t squared plus 3t minus 10 by t minus 2, right? And here, t squared plus 3t minus 10 can be written as t
plus 5
times t
2
minus 2.
minus 2
Yeah. So here,
divided t minus 2
yeah, t minus 2 can be cancelled, right?
equals 7.
Yeah, so the limit that is 7. So we know this point is removable discontinuity. And how to make it continuous, guys? So here we can give a new function, that is if t does not equal to 2, right? Then the function that is t squared plus 3t minus 10 t minus 2. And if t equals to 2, then the function equals to 7. So, yeah, so we know that the function, yeah, is at the point t equals to 2, right? So this is how to extend a function to be continuous at the removable point. And then the second type of discontinuity, the second type, we call it jump discontinuity. Jump discontinuity. That means the left-hand limit exists, and the right-hand limit also exists, but they are not the same. So at this time, we call the point x0 here, that is jump discontinuity. So we have to do the exercise above, that if I give the function that is x plus 2 if x is larger than 0, and x minus 2 if x is smaller than 0. And we have gave the graph here that is like this, right? So we know here the right-hand limit and the left-hand limit, they both exist, but they are not equal. So here the point x equals to 0, we call it jump discontinuity. Because here the graph jump, right? From this point to here. So we call this point jump discontinuity. It is more easier to understand than removable discontinuity, right?
Yes, Laoshi.
So this time, we call it jump discontinuity, discontinuity. And the last type we will learn today, that is infinite discontinuity. For example, for the function 1 by x, for the function 1 by x, as x approaches 0, here, if x is larger than 0, so here you can see if x approaches 0, then the limit that is infinity, right? That is infinity. Very, very large. So at this time, we call the point x equals to 0, that is infinite discontinuity. So these are three the common types of discontinuity we will meet in the following days. So here you have to remember that especially the first two, removable discontinuity and jump continuity. So now I will give you 2 more exercises to practice. And
Also, can you give us an example of the jump discontinuity?
Jump. This function.
Discontinuity. Yeah, like examples of it.
You say another example, except that, right?
Another example, please, Laushi.
Okay, another example, okay? For the jump discontinuity, okay? Here, f of x. Okay, let me find one. For this function, if x is smaller than -1, then the function is 2x plus 5. If x is larger or equals to -1, then the function that is 1 by x. So now tell me the type of discontinuity. So here for this question, you will find that the function changes at the point x equals to -1, right? So we will consider this point maybe the discontinuity point, right? So here we can find that as x approaches -1 from left, that means x is smaller than -1, right? So yes, the function here, that is 2x plus 5, right? So that equals to 2x plus 5 as x approaches -1 from left. So we know that equals to 2 times -1 plus 5, so equals to 3, right? That means left hand limit exists and equal to 3, right? And now we will calculate the right hand limit. As x approaches -1 from the right hand, then here we know that is the function now equals to 1 over x, right? So 1 over x, and that equals to 1 by -1, right? And now we know that equals to -1. And this means at this point, right hand limit also exists, right? And that equals to -1. But here we find that left hand limit does.
How can you count it is exists right hand and left hand?
Because we calculate it is a value -1 here. We substitute -1 into this function here.
Okay.
Yeah, we can get a constant. That means it exists. So here we know that left hand limit exists and the right hand limit exists, but they are not the same, right? So here, does not equal to, right? So this point x equals to -1, that is jump discontinuity. Because left exists, right exists, but they are not the same. So now we call it jump discontinuity. Can you understand now?
Okay, so Laoshi, you can only get the jump discontinuity if both the right hand and the left hand exist, but they are not corresponding or the same.
Yeah, they are not the same.
Okay.
So, okay. And for this example, it is very special. Guys, can somebody find another point that also might be discontinuity? Can somebody find for this example? Look at here, this function. If x is larger or equal to -1, the function that is 1 over x, right? But we know that x should not equal to 0, right, guys? 0 is larger than -1, right? But this function requires x should not be 0. So except this point is discontinuity, and there is another point that is also discontinuity, that is x equals to 0. Because as x approaches 0, that 1 by x approaches infinity, and we call it infinite discontinuity, right?
Yes, Laoshi.
So for this example, it has 2 discontinuity. The first, x equals to -1, this is jump discontinuity, and x equal to 0, this is infinite discontinuity. So for different kind of questions, you should consider all the conditions and all the points may be discontinuity. Okay, so this is another example to explain what is jump discontinuity. And now I will give you another one. Okay. So for what value of A is a constant. For what value of A is the function f of x plus a if x is smaller or equal to 0, cosine x if x is larger than 0, and this function continues at the point x equals to 0. So how to get the constant?
Okay, let's see. I think we have to say x plus a is equal to the second function, like asx then we'll find the constant.
Yeah, to find the constant A, we should know that the definition of continuous at a point, right? So here you should make the constant A satisfied the continuous. So to try to get A equals to what value, that the function is continuous at this point. This is a specific constant.
Probably a negative number.
Amato.
Bro, mute yourself.
Okay, for this question, the question wants you to find the value A, to find the value A. Of course, I know A can be any constant. A can be any constant. So choose with constant to make the function continuous. That is the questions we want to solve. So for this one, I see most of you can find the ways to solve it. That first, we have to know that f of 0, right? F of 0, that equals to, here, if x equals to 0, that we have this expression. So that is 0 plus a equals to a. And this step, most students forget to write. This is very important to check if a function is continuous at a point, because the continuous continuity test, that is to check that the limit equals to the value of the function at this point. So this is the first step to check. Don't forget it. This part, don't forget it. And then the second, we should check the limit, right? And the limit, we know the first we consider as x approaches 0 from left. And if from left, that the function is x plus a. So here, that is 0 plus a equals to a, right? And then we consider if x approaches 0 from right. Now here, we know the function equals to cosine x, right? So here, that equals to cosine 0, that equals to 1. And from the definition here, if I want the function is continuous, at this point, x equals to 0, that must be left-hand limit a equals to right-hand limit 1 equals to the value of the function at 0, a, right? So of course, a equals to a, right? So now we know that the conclusion that a equals to 1, that makes the function continuous at this point. So can you understand, guys? This is the final result. This is the final result. And I see some students write that a does not equals to 1, so the function is not continuous at this point. Pay attention to the question. I want the function to be continuous at this point. So it should be continuous at this point, and a can be any constant. So here we know a equals to 1, that the function is continuous. So can you understand for this question?
Yes.
Okay. So I will give you another similar one to check if you can understand. Also for what value of b is the function gx equals to x bx squared continuous at every x. Okay, so for this question, we know that for the left, if x is smaller than -2 here, gx equals to x, and this is a continuous function. And if x is larger or equal to -2 here, that bx squared is also a continuous function. So there is only one point, x equals to -2, may be not continuous. So we only have to consider this point. So here we first write f of -2. And f of -2 here, we know that equals to b times -2 squared, right? So here we get that is 4b. And then we calculate the limit here. The limit here as x approaches -2 from the left. And here the function gx, sorry, here that is gx. So here the function gx, that is x, right? So that is x as x approaches -2 from left. So here that is -2. And another one from right hand. So here that is x approaches -2 from right. Then gx here equals to x approaches -2 from right. So here that is bx squared, right? So that equals to 4b. And then for the last step, we want these three values are the same. So that means 4b equals to -2 equals to 4b. So here we can get that b should be -1/2. -1/2. So here is the conclusion, the result of this question. Can you understand, guys? Yes. Okay. Okay.
It is jump this continuity, or can we say that this limit is jump discontinuity?
No, if we let b equals to -1/2 here, if we let b equals to -1/2 here, the function that is continuous, right? But here, if b equals to 1, so here we can get that the function that is x and x squared, right? So now for this case, if b equals to 1, we got that the left hand limit, that is -2, and the right hand limit, that is 4, right? So here we know the left hand limit exists, right hand limits, but they are not the same. So we can call if b equals to 1, that the point -2, that is a jump discontinuity. But here we want it to be continuous, right? So b equals to -1/2, that is continuous here. Can you understand?
So if Laoshi, if this question is talking about it being continuous, so what if the question doesn't state that it has to be continuous, or you have to find what kind of limit it is? Can you say this equation is a jump discontinuity?
So the result, of course, according to the question, the way of the questions, right? So you just pay attention to the questions, then give the correct answer according to the question. That is okay.
Okay, Laoshi.
Okay.
Okay, Laoshi.
And other questions? No? Okay. So for the last part of this chapter, we should know the properties of continuous functions. And if a function that is continuous, that means the function is continuous in the domain at every point of the domain. That the function that is a really good function. So it has many properties, good properties, such as sums, differences, products, and so on. So these are the properties of continuous functions. Of course, I will give you the slides. And then here, that is the composite. Now, for the composite functions, we will talk about later when we learn the next chapter. So by now, we have learned this chapter. We have finished this chapter. And in this chapter, the most important point, that is to calculate the limit. That is very important. So for the last 25 minutes, maybe, we will have a chapter test because our final marks should contain a test mark, right? So here I will give you I will give you a small test, and don't worry. The test, just try your best to work it. Just try your best to work it. And if you have finished, just take a picture and then send it to my email with the title test. So that is the test for you. And the marks of the test, I will give you if you send your answers. Can you understand? As long as you send your pictures, your answer sheet, no matter how well or bad you did, I will give you the test marks. But you should practice.
Where are the tasks, Laoshi?
So here I will give you 3 questions, and now is the test time. So here.
Okay, Laoshi.
Okay.
Okay, you should send it by WeChat or email, Laoshi.
Email is better. Send it to my email.
Okay.
Okay. So the test question, the first one. And the last one. Okay, here are the 3 questions for the chapter test. And don't send your answer sheet to the WeChat group. Just send it to my email, and I will write my email here.
Laoshi, how about the deadline?
Uh-huh.
How about the deadline, Laoshi?
So you should date it now.
Now, right now.
Yeah.
Oh my gosh. Okay, Laoshi. But I was thought like our class is already over.
Laoshi, it would be
You're
better
gonna
for
give
us.
us homework, but
No,
we have to submit right now.
homework is not test. Okay. So
Laoshi, it would be better for us if we could have studied a little bit.
Yeah, Laoshi.
the questions are not hard. And
But math is always hard, Laoshi.
I have told you that no matter how you did the test, I will give you marks if you send it. So
Full mark?
So just try to practice, okay?
Laoshi will give us full mark?
For the chapter test. For the chapter test. Of course not full marks.
I thought you said you will give us the full mark. If it's wrong or right, you don't care.
No,
You don't have to have marks from today.
Testing.
Laoshi.
Yes.
Does this number will included in our, the final semester?
Mm-hmm. Yeah, the chapter test, the marks of chapter test is contained in the final mark.
Oh my gosh. It's really
I think the first two.
Okay, that's how we actually want some time.
The first
to
two
solve
are
this.
easy, so just try to work it out, okay?
Okay, Laoshi. I'll try my best.
Laoshi, sorry, I have a question.
Okay.
Do we need to write our student ID on the answer list?
Of course.
Oh, okay. I saw it only on the email box.
Oh, okay. Better on the answer sheet.
Okay, Laoshi.
I have received 2 students' answer sheet, and they are all correct. So try your best, guys. And I will give you 5 more minutes. So you should complete in 5 minutes, guys.
Lasha, could you please send your email on our WeChat group?
Okay.
Lashi, can we get more 5 minutes, please? We need to send you email. That's why it needs some time.
The first letter is not capital. I will send again. Okay, I will give you some hint, but only for this time, because this is the first time we have chapter test, and after we complete every chapter, we will have a chapter test. So I will give you some hint this time, but you should be serious, take math serious, because as you said, math is always difficult, right? So here I will give you some hint and you can correct your answer if you did wrong and send it to me as soon as possible. So first here, if x approaches infinity, so here we know that 1 by x approaches 0, right? And 1 by x squared approaches 0. So we can get the result of the limit of the first one, right? So I think this question is easy. And for the second one, first we find the highest power, that is power 3. So here we can divide x power 3, both the numerator and denominator. So here you can try to divide x power 3 like this. So that is 1 plus 2x by x3 minus 1 by x power 3. And here that is x squared by x power 3 minus 3x by x power 3 plus 5 by x power 3, right? So here you can see if x approaches infinity, so here approaches 0, here approaches 0, and here all approaches 0. So we can get that is 1 by 0, right? And as we say, that is infinity. That means the limit does not exist. So this is number 2. And and I saw most students did correct number 2. And for the last one, so here we see sine 2x and sine 2x here in numerator and denominator, right? So we want to use the important limit. And here, if we want to use the important limit, we want to know that the limit that is sine x over x, right? So here we can divide x together here. So as we can see, that is 1 minus sine 2x by x and 1 plus sine 2x by x, right? So here, if we want to use this formula, we want here that is 2, and here we times 2 to make it same. So here, similar, we times 2 here. So as x approaches 0, this part approaches 1, and this part approaches 1. So we can get that is 1 minus 2 by 1 plus 2, right? So we can get that is minus 1 by 3. So I think the questions are not so hard. Just use the things we have learned in this chapter. And limit is a very important tool to do some research on the functions. So next chapter, we will learn other definitions. We all use limit. So here you should understand and master how to calculate limit. So I will give you some time to complete your test, your answer sheet, or correct your answer sheet. So you have to send your answer sheet before before this time, Beijing time. That is 5:30 p.m. Beijing time. So you have 30 minutes to correct your answer sheet and then send it to me. That is your...
Laoshi, I can't send to your email.
Okay. And I think I have given you full marks for this time, for this test, right? Because
Thank you, Laoshi.
because I have gave you the answers. So
so kind of you, Laoshi.
Because this is the first time we take test, right? And as math is so difficult, right? so I will try my best to help you to learn math, but you should take it serious, okay, guys?
Okay, Laoshi.
We are badly serious, Laoshi.
Okay, so try to finish the test and don't forget to send it to me because that is your mark, okay?
Laoshi, we already send you.
Okay. So I will check one by one and I will give you the list maybe this evening or tomorrow that how many students I have received the homework and the test. Okay, I will give you the list together. Okay, guys. Don't forget to send it to me. Okay, so see you next week. See you next week. Bye-bye. Bye-bye.
Bye, Laoshi.
Bye.
Laoshi, you're looking so beautiful today.
Thank you.
Ma'am is blushing. Ma'am is blushing.
Okay.
Laoshi, your t-shirt is so beautiful.
Just a black t-shirt.
Yeah. And I'm also really fond on black.
Okay.
Son, don't flirt.
Bye. Bye.
Bye.
Bye.